Welcome to today's paper reading. Today's paper is titled, Scaling Open Source Multimodal Data by 10x, a multimodal dataset with 1 trillion tokens. This paper introduces MINT-1T, a large-scale multimodal dataset, by Awadalla and colleagues from the University of Washington and Salesforce Research. The MINT-1T dataset is the most extensive and diverse open-source multimodal interleaved dataset to date. It includes 1 trillion text tokens and 3.4 billion images, representing a 10-fold increase in scale compared to existing open-source datasets. The dataset incorporates previously untapped sources such as PDFs and AR-14 papers. By sharing the data curation process and releasing the dataset, the community benefits significantly. Experiments demonstrate that large multimodal models trained on MINT-1T can rival the performance of models trained on the previous leading dataset, Obelix. Figure 1 provides an overview of MINT-1T, the largest and most diverse open-source multimodal interleaved pre-training dataset. It highlights that MINT-1T contains 1 trillion text tokens and 3.4 billion images, sourced from diverse formats including HTML, PDFs, and AR-14 papers. This scale and diversity make MINT-1T a significant advancement over previous datasets, which were smaller and less varied. Figure 2 presents samples of multimodal documents from the HTML, PDF, and AR-14 subsets of MINT-1T. Each document contains a sequence of images interleaved with text. This interleaved data format has been shown to enhance question-answering performance in Flamingo-style models and improve the training of large multimodal models. MINT-1T is the first open-source dataset to scale interleaved datasets to 1 trillion text tokens, significantly contributing to the diversity and scale of multimodal data available for research. The introduction highlights the significance of large open-source pre-training datasets in advancing data engineering and training transparent models. Early datasets like C4 and the Pile were crucial for training initial open-source large language models such as GPT-J and GPT-Neo. However, there is a growing gap in multimodal training data between open-source and closed-source models. To address this, the authors introduced MINT-1T, a large and diverse open-source multimodal interleaved dataset. MINT-1T contains 1 trillion text tokens and 3 billion images from diverse sources, overcoming the limitations of previous datasets. This new dataset presents significant engineering challenges but offers substantial benefits in terms of scale and diversity. Table 1 provides a survey of multimodal interleaved datasets, highlighting that current open-source datasets are smaller in size compared to proprietary ones. Notably, MINT-1T stands out by including data from PDFs and AR-14 documents, in addition to the common HTML data sources found in other datasets. Figure 3 illustrates the comprehensive filtering process applied to the MINT-1T dataset, which includes HTML, PDF, and AR-14 papers. The process involves the removal of tokens throughout the data pipeline to ensure high-quality data. Specifically, the dataset contains 922 billion HTML tokens, 93 billion PDF tokens, and 9 billion AR-14 tokens. Additionally, the filtering process includes measures for text and image quality, ensuring that the final dataset is both diverse and high quality. The dataset construction process involves sourcing data from multiple modalities including HTML, PDF, and AR-14 documents. The dataset totals 922 billion HTML tokens, 93 billion PDF tokens, and 9 billion AR-14 tokens. Data is processed through specialized pipelines for each source type, ensuring quality through filtering and deduplication methods. This includes removing non-English documents, filtering out NSFW content, and deduplicating both text and images to maintain a high-quality dataset. Figure 4 illustrates the distribution of text tokens per document for both Obelix and MINT-1T. Notably, the HTML subset of MINT-1T exhibits a distribution closely aligned with that of Obelix. However, documents sourced from PDFs and AR-14 demonstrate significantly longer lengths compared to HTML documents, underscoring the advantages of incorporating diverse data sources. Figure 5 illustrates the distribution of images per document in MINT-1T compared to Obelix. It highlights that MINT-1T documents generally contain more images than those in Obelix. Specifically, the HTML subset of MINT-1T has more images than Obelix, and within MINT-1T, PDFs are slightly more image-dense than HTML documents, with AR14 being the most image-dense subset. In this analysis, the composition of documents in MINT-1T is compared with Obelix. A random sample of 50,000 documents from each dataset was taken, and the number of text tokens and images per document were analyzed using GPT-2's tokenizer. Outliers were excluded to ensure a fair comparison. The results show that the HTML subset of MINT-1T closely matches Obelix in token distribution, while documents from PDFs and AR14 are generally longer. This highlights the value of sourcing data from diverse formats. Additionally, a latent Dirichlet allocation model was used to assess domain diversity across the datasets. The analysis reveals that Obelix is heavily focused on humanities and social sciences, while MINT-1T's HTML subset offers a more balanced representation across domains. The PDF subset of MINT-1T shows a higher concentration of science and technology documents, reflecting the typical use of PDFs in scientific communication. Figure 6 illustrates the distribution of document domains within the MMU dataset for Obelix and subsets of MINT-1T. Notably, Obelix shows a significant concentration in humanities and social sciences, which is not observed in MINT-1T's HTML subset. Conversely, the PDF subset of MINT-1T exhibits a higher proportion of science and technology documents, likely due to the format's preference in scientific communication. The model architecture is based on XGenMM, utilizing a ViKH Vision encoder and a Phi-3 mini-language model. Training is conducted on 32H100 GPUs for 1,920 GPU hours using the OpenFlamingo codebase. Evaluation methods include in-context learning, multi-image reasoning, and performance on captioning benchmarks. Table 2 presents the results of in-context learning evaluations conducted on three 4.6 billion parameter multimodal models trained on a mixture of image, text, and interleaved sample documents, totaling 10 billion tokens. The models were assessed using 4 and 8 in-context learning examples, with each evaluation run repeated for 3 trials to ensure reliability. The table reports the mean performance scores along with the standard deviation, highlighting statistically significant performance gaps and instances where models performed equally. This comprehensive evaluation provides insights into the effectiveness of different training approaches and their impact on model performance in multimodal tasks. Table 3 presents the performance metrics of different models on the image reasoning benchmarks MMMU and Mantis eval. The Obelix model scores 37.6 on MMMU and 44.2 on Mantis eval. The MINT-1T HTML model achieves 35.2 on MMU and 41.5 on Mantis eval. The MINT-1T model, trained on a mixture of HTML, PDF, and AR14 documents, outperforms Obelix on MMMU with a score of 41.3 but scores lower on Mantis eval at 43.3. This indicates that while MINT-1T excels in simpler reasoning tasks, it faces challenges in more complex multimodal reasoning. Figure 8 illustrates the performance of models on captioning and visual question answering (VQA) tasks. Notably, the HTML subset of MINT-1T demonstrates superior performance in VQA tasks compared to Obelix. However, it lags behind in captioning benchmarks. This figure provides a comprehensive view of the average in-context learning performance across these tasks, highlighting the strengths and weaknesses of each model. Table 4 presents the results of the IDEFIX2 model when trained on Obelix and MINT-1T HTML datasets. The model's performance is evaluated using 4 and 8 in-context learning examples, with each evaluation conducted over 2 trials. The table reports the mean performance and standard deviation for each dataset, highlighting the differences in performance between the 2 datasets. Figure 9 illustrates the impact of different model architectures on in-context learning benchmarks. It shows that XGenMM models achieve marginally better performance when trained on the Obelix dataset compared to MINT-1T's HTML subset. Conversely, IDEFIX2 models demonstrate a slight advantage when trained on MINT-1T HTML over Obelix. This highlights the nuanced differences in performance based on the dataset and model architecture used. In the realm of multimodal datasets, Flamingo, CM3, and Cosmos were pioneering works that introduced large-scale interleaved datasets. Following these, Obelix and Multimodal C4 emerged as the first open-source multimodal interleaved datasets. More recent datasets like Chameleon have further scaled these efforts. In the development of large multimodal models, Flamingo was a foundational work, which was later adopted by open-source models such as OpenFlamingo and IDEFIX. More recent models like IDEFIX2 and MM1 have continued to build on these data mixtures. In this work, the authors introduced MINT-1T, the first open-source trillion-token multimodal interleaved dataset. This dataset is a significant resource for the research community, particularly for training large multimodal models. The authors have taken measures to ensure the safety of the data by filtering out harmful content and removing personally identifiable information. However, they acknowledge that more work is needed to further enhance the safety of multimodal internet data. Future research should focus on training models on larger subsets of MINT-1T, developing improved filtering methods to enhance data quality, and curating multimodal sequences from additional sources. Thank you for watching.